Now that the spatialite database has been created, I'll populate it with the 8 vector layers. I'll begin by importing the lakes KML layer into the database. So I'll go to the database menu and open up the database manager, expand spatialite, and expand my database connection. And there's 2 buttons here. This is for importing data, and this is for exporting data out of the database. So I'm going to use the input database button. I'm going to, from the drop-down menu, choose my lakes layer. The table here is what the layer will be called in the database. I'll just call this lakes. And I need to specify down here the source spatial reference ID and the target spatial reference ID. Since this is a KML layer, the source SRID is 4326, geographic, and the target is the UTM EPSG code for my data, which is 26910. I'm also going to choose to create a spatial index. There's really very few circumstances where you wouldn't want to do this. This will just make the data render faster when it's brought into QGIS. And I'll click OK to import it. Import was successful. I'm going to click the refresh button up here, and I'll see lakes appear as a layer in my spatial database. And you can see it has a little polygon icon. And if I click the preview tab, I'll get a preview of the lakes. So this database manager is a small version of QGIS browser in a way, just for database data. You'll repeat this step to import the streams in the database as well. Okay, so here I've imported the streams layer 2. So here's the streams with the line icon next to it in the database. Streams and lakes were the final 2 layers that required a CRS reprojection. The remaining 6 layers are all in UTM and can be imported into the database without changing the spatial reference on the way in. So this will be the same process as with the stream and lake layers. The only difference is that I won't be specifying a different input and output SRID on the way into the database. So for example, I'll import roads now. So I'll click the import button, set the input as roads, call the table roads. And I still want to specify the source and target SRIDs. It's just that they'll both be the same, 26910. I'll choose to create a spatial index and click OK. Import was successful. And if I refresh the database, I'll see now that roads are in there as well. In the lab, you'll repeat these same steps to import the trails, the watersheds, the ranger districts, vegetation, and the forest boundary layer into the database. Okay, I've gone ahead and imported all the layers into the database. Now that they're all in there, I can go into QGIS here and right-click and remove all of these layers because I don't need them. And I can add the data from this spatialite database to QGIS in 2 ways. From the database manager, I'll expand my database. And if I wanted to add a layer from here, I can right-click on it and choose Add to Canvas. Click Close. So here is the forest boundary being pulled from the spatialite database. I can also use the Add Spatialite Layer button, select my database and click Connect, and it'll show me all the layers in my database. I can click the remaining 7 that I haven't added and click Add. Okay, so now I have my QGIS project with all the data being pulled from the spatialite database that I've created. Now that I have a connection to this database, I can also open up QGIS browser and click the refresh button up here, and I'll see the same connection to the same database in QGIS browser. In this lab, we took data in several different file formats and coordinate reference systems and normalized them. They're all now in the same coordinate reference system. They're all clipped to the forest boundary and are all stored in a geodatabase, so they're all in the same file format. This methodology of project management has the benefit of creating a working copy of the data. The raw data still exists. I still have the original coverages, KML files, and shape files. Therefore, if I accidentally delete or corrupt a data set, I still have the originals to fall back on. Additionally, The data all now reside in a tidy database, and since they're all in the same coordinate reference system, I can run any geoprocessing or analysis tools against them, knowing they're all in UTM Zone 10 NAT83.